Hi everyone, welcome to this episode of Kuiper Labs. Today in this video we're going to be talking about energy transformations, often known as energy conversions, thinking in our unit on energy and how we encounter different types of energy in lots of different everyday situations. Alright, so we'll start with a quick little overview and then we're going to go through some examples and definitions. Alright, so we're talking energy transformations, but I also mentioned this term energy conversions. Okay, is another way that this is often referred to. We're in situations where we're converting one type of energy into another type, and this is in situations where energy is causing change. Okay, so in a situation, a scenario where the energy that's involved in this process is causing a change in the real world somehow. Whether something's being burnt and it heats up something else, whether shining a light on something makes it warmer, or whatever. That in those situations where energy is causing change, we're getting a conversion of energy from one type into another type. Now we come across these sorts of things in everyday life in all manner of ways without even realizing it. And so part of what we're going to try and achieve in this is to help you to see that sort of thing a little more clearly, with some examples of how how that conversion happens. Okay, so remember that we've talked in the past, in the previous video, that what we consider as energy, we tend to put into two broad categories. So kinetic, where we're thinking about motion, and potential, which is where we're thinking about some energy that's stored in objects. And that can, we talked about it in terms of chemical, we might also term, in terms of, say, electrical. Some of the other examples we talked about, elastic, gravitational. There's other types as well that we could identify as forms of potential energy, where that energy we consider it to be stored in something. Okay, and so we've come across all these different sorts of types. Okay, and then some of the other types names that we've talked about. So we talk about heat. What we as scientists would tend to prefer the word being thermal. We've also got light, we've got sound. Okay, there's some other sorts of examples that we're really familiar with of types of energy. Okay, so you need to be really familiar with what some of these labels are, but for these purposes of this video, we're thinking about how energy can change from one form into another. Okay, and so I'm going to give you a couple of quick scenarios. Okay, and that'll help to illustrate this. Okay, so we're going to talk about burning a candle. Okay, so we've got our lovely little candle over here. It's got a wick. It's got a fairly average looking flame. You can see why I'm a science teacher and not an artist. Okay, so we have a candle that's burning. Okay, so when we burn a candle, there's a number of different things that we encounter here. One of the reasons that we do it is for heat. Now, if you were purely heating by burning a candle, it would be a bit of a slow day indeed, but we notice that you get a lot of heat out of a candle that's burnt. Okay, we also we get light. Okay. You can see the candle flame. We can see the colours of that flame. And so what we're getting at here is that the energy that we perceive as heat and light, so remember heat, that we're going to keep using this term of thermal till we get a little more comfortable with it, is that energy had to come from somewhere. It didn't just kind of magic out of thin air. And so these forms of energy weren't originally in the candle, in terms of, it wasn't just like a little heat box that all of a sudden you kind of crack open the top and so the heat escapes, or the light escapes. That energy came from a different form to start with. And we would say that it's stored in the chemical that a candle is made of, which is wax. Okay, and so it's energy that is stored, so it's going to be a type of potential, and it's stored because of the nature of the substance that the candle is made of, which makes it a chemical potential energy. So we have chemical potential energy converting into both heat and light when we burn a candle. Okay, so we've got an energy conversion going on here. Alright, so you can see that we've got before and we've got after, and we may have maybe more than one. Okay, so you might end up with more than one type. Alright, let's look at another example. Okay, let's go to every naughty student's favorite thing, an elastic band slingshot. Okay, again, apologies for the rubbish drawing. So we've got our rubber band, we've got our little slingshot bit at the back. Sorry, I just realized it doesn't actually come up on the screen very well. There we go. Okay, so slingshot that gets pulled back and then releases our little projectile, spitball, rubber ball, whatever, don't care. So what we have here, okay, we've got a conversion going on, energy conversion. Now, we know at the end, our little ball, our little projectile, as the scientists would call it, is moving. Okay, so it's gone from here and it's traveling some distance over here to land, hopefully somewhere safe and not hurt anybody. So the type of energy that we have at the other end is called kinetic, because it's a moving object. Now that energy that it has, because it's moving, came from somewhere, because it wasn't moving all the time. It started off still. And it started off still, but it was in a rubber band that was pulled back. So remember, it's being stored in the rubber band, so it's a type of potential. Now in this situation, we're talking about elastic potential. Okay, so that it's stored in the rubber band, so stored in rubber band, and then the conversion happens as the ball flies through the air. Okay, so we've got a conversion happening, and the energy has caused a change, that the ball is now traveling across the room when it wasn't before. Okay, so we have elastic potential transforming into kinetic. Okay, and so let's think about one last example to kind of finish things off. Okay, we're thinking about a light globe. Okay, so a light globe, like an old-fashioned kind of, we call this an incandescent globe, because it works, because we want to get a little bit of metal in here really hot. Globe. Okay, and so same sort of situation that we had, similar sort of situation that we had before with our candle. We get two main things out of this one. We get light, that's the purpose of a light globe, but we also get an awful lot of heat. If you've ever ended up touching a globe that's been on recently, you'll certainly know what this feels like. Okay, but so we have light and we have heat. That energy, again, didn't come from nowhere. It wasn't, packed into the light globe just waiting to be released. It was energy that came from somewhere else. It was stored in the, so it was stored in some way in that light globe. Now the thing about, we know a light globe doesn't store energy by itself when it's just sitting in a box. It needs to be plugged into something, and that is electricity. So we're thinking in this situation about electrical potential energy. Okay, so that once you plugged it in, in the electricity in the plug, in the circuit. Okay, it's a bit vague, but just for this situation it works. Okay, and so then we get light and heat in our globe. Okay, so in this sort of situation, we're just thinking about it in terms of some scenarios, some situations where energy is being changed from one type to another, maybe more than one type. And in situations where that energy is causing a change. Alright, so I hope that clears things up for you a little bit. Thanks very much for watching. Bye for now.